Mercury. Here we see an image of Mercury taken by the first spacecraft to fly past. That was back in the 1970s. And until about 2012, this was the best image we had of Mercury. And you can see it's made up of a mosaic of images that were all then pieced together. What we knew about Mercury, some of the basic properties. Mercury, no moons. Mercury and Venus are the only two planets to not have any moons. Proximity to the Sun may have something to do with that. And then Mercury also has no atmosphere. Which you can kind of tell from the picture because there's this stark boundary between the planet and space. And Mercury also has no active geology. So we think of Mercury essentially as a dead world. It is not doing anything to change its conditions today. Composition. Recent spacecraft in orbit around Mercury is called Messenger. Which is giving us much better information about Mercury than we had in the 70s. And one of the things that it can measure is the density of Mercury. And we find that the density is slightly less than Earth's density. So Mercury is not as compacted as Earth. And that has something to do with the size of Mercury. Mercury is much smaller than Earth, so its self-gravity, how strong does gravity pull it together, is lower and doesn't compress it quite as much. But when we look at the structure of Mercury, we see that its core is quite large, and it is metallic. And so that gives it a higher density than you would expect for a planet this size. And then the outer part of Mercury, the crust, is quite thin, and it is composed of silicates. So the surface of Mercury, everything out here, is silicate rock. So it has a silicate rock surface, but the bulk of its interior is metallic, which is mostly iron. To measure the rotation of Mercury, we actually bounced radar off of the planet, and so we measured how fast one edge was receding and how fast one edge was approaching, and from that we were able to determine how fast it takes Mercury to rotate. Normally we would look for surface features, but because Mercury's orbit is so close to the Sun, we cannot see a lot of detail because we only see Mercury in twilight. We don't see it against a nice dark sky, so the contrast isn't there to see surface features. So we used radar. And as you can see, what we found was Mercury is in what's called an orbital resonance. That means that there is a ratio between the time it takes to orbit around the Sun and the time it takes to rotate once on its axis. And in the case of Mercury, that ratio is 2 to 3. Every 2 orbits, Mercury rotates 3 times. So it takes Mercury roughly 88 days to go around the Sun. That is a Mercury year, and it's roughly 59 days for one rotation. So that's a Mercury day. So it has a very bizarre day-night cycle, and this resonance is very much due to the Sun. It's the Sun's gravity pulling on Mercury and essentially locking on to one side, so it keeps that side coming back to the same place every 2 orbits. Conditions on Mercury, temperature-wise, not very pleasant. As you can see, our high on Mercury is 800 degrees Fahrenheit, not too surprising given how close it is to the Sun. A little more surprising is that low, negative 300 Fahrenheit, but that's because there is no atmosphere. So on the nighttime side, you basically have bare rock exposed to space. And because of that slow rotation, there's lots of time to cool off. And so this extreme between day and night is actually the largest temperature difference for any planet in our solar system. So Mercury, very inhospitable as far as temperature is concerned. Surface features on Mercury, of course there's craters, everybody has craters, and these are always due to impact. So each one of these little circular features is showing us a place where something hit Mercury in the past. In this case we see some stuff that was shot out of the crater. That's called the ejecta blanket. Mercury with no active geology, lots and lots of craters. Nothing is happening to erase those craters over time. Scarps. You see this shadow feature right here. That's because this side has slumped down. And that ridge or cliff that you see right here is the scarp. And essentially, part of the planet, when it first formed, would have been molten in the interior. It has since cooled and solidified. And when things cool, they shrink. So the interior kind of shrank away from the crust. And so the crust fell downward, and that creates these cliff-like features called scarps. When Mercury had a molten interior, there was lava in the interior that was released after impacts, possibly also volcanoes. And so you do see regions that are relatively crater-free. Obviously there is a crater in this image, but most of this image you do not see craters. And so that indicates that lava had erased the craters that had occurred there. But it's been a very, very long time since Mercury had any molten material in its interior.